Hey everybody, welcome back to another video on absolute value functions. Here we're solving them, but I'm calling these two-sided absolute value functions. So in these three examples I have absolute value expressions on each side of the equal sign, and so that's what we're gonna do. That's why I'm calling these two-sided. So when you're solving two-sided absolute value equations, you want to basically just rewrite it without the absolute value bars and then solve for your variable, okay? And then in the last video, it wasn't set equal to another absolute value equation, but you set it equal to like that number and then that number if it was negative. So what you do is you completely negate one side. So I will set up my second solution or equation, whatever, and I'll just flip all the signs. So I'll make like the right hand side say negative 2e, and instead of minus 3 I'll write plus 3. I could have easily just said minus e and kept these the same. It really doesn't matter which side you choose to make negative, as long as you change the signs on one side of the equal sign. So now that I have these set up, I'll go ahead and solve them. So if I have e equals 2e minus 3, I need to get all my e's to one side, right? So, sorry, I got iPads updating in the background. So I got e minus 2e, that's going to be negative e equals negative 3. So if I am trying to get rid of a negative by a letter, I should divide by negative 1. And so I get positive e equals positive 3. All right? And now on the one where I change the signs, I can add 2e to the other side and make this a plus sign. There we go. And so that cancels it there. So I have 3e equals positive 3. And so I need to divide by 3. And I get e equals positive 1. And that's basically all there is to it. With each and every problem I do, I always encourage you to look at the graph. And so when you graph these, you should have, you graph the left-hand side of the equation on one side and the right-hand side, on one line. So this was absolute value of e, I graphed it as absolute value of x, and then I changed this to say 2x minus 3. And so you see that you have two v-graphs, and they intersect twice, here at 1, 1. So we just found out the x-coordinate, so 1, and then 3, 3, so 3 was that x-coordinate. So yeah, that's really all there is to say about this one. So let's move on to the next one. I will set it up, and I will say 5f equals 3f plus 1. And then I'll go down here and I'll set up my second one and just change the signs on one side. So how about negative 3f minus 1? Okay, so they're both set up. Now just solve for f. I can minus 3f over. And so I have 2f equals 1. So if I divide by 2, I get f equals 1/2, or 0.5. All right, and now let's move on to the next one. I can add 3f to the other side, and that's going to get me 8f equals negative 1. So I'll need to divide both sides by 8. And so I'll get f equals negative 1 over 8. Or if you want to convert it to a decimal, it would be negative 0.125. And so when you graph it, you should have intersections right here. So I'll type in on the left the absolute value of 5x, and on the left, on the first line, I keep messing up Hopefully I'm saying what I'm doing. And then on the second line, I'll type in absolute value of 3x plus 1. And so you see they intersect where x is 0.5 and then where x is negative 0.125. So we're good. And then the very last one, I have something on the outside. And so generally, if you can clear up something on the outside, you should do that first. But I have something on the outside of both of them. So you can do two things. You can get it just on the outside of one side, or you can just distribute it. It really doesn't matter. So what I'm going to do is I'm going to cancel out this fraction on this side. So if you want to cancel out a fraction, you just flip it and multiply. So I'll multiply this by 2 over 1, or just 2. But what I do to one side, I have to do to the other. And so I'll multiply the other side by a 2, or 2 over 1. But 2 over 1 times 4 gives me 8. So I have 8 times the absolute value of g equals the absolute value of 6g minus 2. All right, and then I'm going to write my two equations. I'll write 8g as if I distributed that. So I'll say 8g equals 6g minus 2. And then I'll go down here, give myself some room. And I'll say 8g equals negative 6g plus 2, flipping both those signs. I just choose to flip the signs on the right-hand side because, you know, whenever you're solving these and it's equaling a regular number, you'll set it equal to the positive and negative version of that number. And so it's like I'm just trying to stay consistent, changing the sides on one side, changing the signs on one side. But if I chose to make this 8g positive here and then negative there, but keeping those signs the original is the 6g minus 2, that would also be fine. So I hope that makes sense. But anyway, let's just solve this before I over-explain it. So I know I can minus 6g over, and I'll get 2g equals negative 2. So I'll have to divide both sides by 2, and I'll get g equals negative 1. And that's it for that side. So then go to the side where we the equation where we reverse both signs. And so instead of minusing 6g, I will plus 6g to the other side. And so I'll have 14g equals 2. This means I'll have to divide both sides by 14. And so that fraction will reduce to 1 over 7. If you got the decimal, it'd be about 0.014, and then it'll say like 2857, so I'll just round it to 0.29. So yeah, so I get my two answers. And so what I like to do now is show you the graph. So I'll put it down here. And it should intersect at those two x values. And so you see I have a negative 1 and then a 0.143. I wrote 0.1429. That rounds to 0.143. So yeah. But notice how when I graphed it, I didn't change anything except I changed the letter to an x. But I kept it in its original form, the left side and the right side. So yeah, that's really all there is to say about these examples, is to just make one side negative or completely flip the signs on one side to solve for your second end of the equation. Because remember, these are V-shaped graphs, so you're solving for one side of the V and then you're solving for the other side of the V. That's why you're doing these twice, because it's like a two-sided graph. Other than that, thank you for watching, and goodbye.